value of x in this example, notice that we have a right triangle, so we can use the Pythagorean theorem. The Pythagorean theorem states that the sum of the squares of the lengths of the legs of a right triangle is equal to the square of the length of the hypotenuse, or a squared plus b squared equals c squared, where a and b are the legs of the right triangle and c is the hypotenuse. Since our legs have lengths of 6 and 8, and our hypotenuse has a length of x, we can set up the equation 6 squared plus 8 squared equals x squared. 6 squared is 6 times 6, or 36, and 8 squared is 8 times 8, or 64. So we have 36 plus 64 equals x squared. 36 plus 64 is 100, so we have 100 equals x squared. Now to get x by itself, since x is being squared, we must take the square root of x, and if we take the square root of the right side of the equation, we must also take the square root of the left side of the equation. On the left, the square root of 100 is 10, and on the right, the square root of x squared is x. So our answer is 10 equals x.
This updated 3rd edition addresses the mathematical skills that a programmer needs to develop a 3D game engine and computer graphics for professional-level games. Mathematics for 3D game programming and computer graphics. 3rd edition is suitable for advanced programmers who are experienced with C++, DirectX, or OpenGL. The book begins at a fairly basic level, covering areas such as vector geometry and linear algebra, and then progresses to more advanced topics in 3D game programming such as illumination and visibility determination. It discusses the math first. Then it presents how to translate the math into programs. By providing the math behind the effect, screenshots of the results, and samples of code that translate the math so that the effect is achieved, readers get the full story rather than only a mathematical explanation or a set of code samples that are not clearly drawn from mathematical expressions. With this revised edition, almost every chapter will provide a programming example taken directly from a real-world game programming context, and based on programs that have been written and used in game engine development.
Let's begin! As odd as it may seem, geometric shapes and the interactions between them are the basic foundations of all video games. They rely on the use of shapes to form graphics, and use 2D and 3D objects in different instances to develop a sense of depth. This is done using a 3D concept called skybox. The term skybox refers to a fixed point in a scene which appears to be in the distance. All other graphics in the game are developed around it. It does not move, even as the figure or object you're moving appears to be in the front of the screen. This gives the game a 3D look. When programmers first begin developing figures and scenes, they start with a basic geometric shape. They begin with skybox and draw lines that radiate from it to the corners. They place shapes into the lines at places to add depth. Then they draw the outline of the shapes. After that, they start inserting colors. This may seem rather familiar, because artists do this as well. We have done it many times during art projects. Giving color to the graphics is a whole different process in itself. It was once done on pieces of paper. Each piece contained the next step in a sequence. It is now done with computers, and each pixel on a screen accomplishes each step in the process of incorporating geometric shapes into a game. Think about this. All the pixels on a TV screen were once colored in by using pieces of paper. To give an example of the pixels, an average TV screen has about 200,000 pixels. An HD screen can have upwards of 18 million. If HD graphics were made with pieces of paper, imagine how long it would take developers to even add a few graphics in. To add even more depth of how video games are created, they're heavily based on patterns to present motion. These patterns are based on patterns within geometric shapes to give a heightened sense of action and a more 3D look. This provides a more realistic look than the originally heavily pixelated games from the early 70s. These also relied on geometric shapes and patterns, but could only show a 2D view of the game. Now, with the development of 3D views, the industry has been revolutionized. Programmers can integrate any shape they want to do just about anything, but it all boils down to this. As long as you learn geometry and understand how to turn 2D objects into 3D objects, you can be a programmer. Be warned, if you want to be a programmer, you have to focus on geometry. That's the main thing developers use when creating a game. For example, there are more uses for geometric shapes in games, not just in the concept of skybox. These include using geometric shapes that are congruent to other shapes, and using geometric shapes by rotating, reflecting, and the use of similarities to make graphics move around the screen during action sequences.